properties of pseudomarkets, we have this paper I really like with Marek on the pseudo second welfare theorem with interesting insights on multi-unit allocation. Please have a look. And also some paper in which we are working, in which we deal with the issues and striking and sometimes non-compatibilities between equal incomes and MB fairness, even in large markets. Okay, so let's go to this paper. In this paper, as I said, we are investigating on the allocation environments with minimum guaranteed utilities, okay? And we develop a concept of fairness when we have, you know, this kind of constraints. It's not super new, so it's based on some other papers like Yilmaz and Atanasoglu and Seturaman, but we applied it to you know, more general environment, allowing for cardinal utilities if you like, and some more general allocation problems. Okay, those minimum guaranteed utilities stem from many possibilities: initial endowments, outside options, or even this could be a novelty for policymakers. Okay, why not allowing the policymakers to use this as an instrument, as a tool, as a policy tool? And we address the issue of making this fairness notion that we will talk about in a moment compatible with you know, well understood properties such as Pareto efficiency and individual rationality, of course. Okay, when we talk about fairness, please, Alex, feel free to tell me when you know, when there are like 10 minutes left or 5. Okay, feel free.
Okay, you have 20 minutes.
Oh, very good. The natural, very efficient, very good. So the natural notion of no MB doesn't work here, okay? Because you can always find very easily an example in which such a notion is incompatible with individual rationality. So we developed a notion of not justifying MB in line with Yilmaz and Atanasoglu and Seturaman, which goes like that. It's quite easy. If an envies Ben, okay, then Ben cannot find Anne's assignment acceptable. Acceptable meaning that guaranteeing the minimum utility Ben is entitled to. Okay, so we are not talking about whether Ben likes or dislikes Anne. Anne's assignment. We are talking about acceptability. Okay, so it's quite a mild condition called no acceptable swap principle. And we also extend such a concept later on in Theorem 5 when we talk about some extended notion in which we don't allow even for chains of swaps, but I talk about that later. Okay, but bear in mind that what we propose here works for even more fine-tuned concepts of not justified MB. Okay, so bear in mind again that we are not inventing anything here. This concept is quite well understood already in the literature, and back to Yilmaz and Atanasoglu and Seturaman. Okay, the model is quite an easy allocation model with a set of agents, set of objects, and a capacity vector for a capacity for each object, right? And an assignment is going to be denoted as X, and each individual obtains an allocation that belongs to a consumption set. For the moment, we are very eclectic about what we mean by the consumption set. Okay, but we impose these 3 properties only: non-emptiness, of course, compact, and convex. Okay. However, in several of the applications and several of the results, we have to simplify them. So we have to simplify the setup, and we will focus on subsimplices, okay, which is the case in which, you know, the sum of your allocated quantities does not exceed some number. Okay, the number does not need to be the same for every individual, but for instance, one example of such simplest is the random allocation, in which CI is equal to 1 for every individual, for every agent. Preferences are represented by utility functions that are assumed continuous, monotonic, and semi-strictly quasi-concave. Okay, semi-strictly quasi-concave is a property in between, you know, strict quasi-concavity and just quasi-concavity, which allows for linear utilities, for instance, but it doesn't allow for plateaus in the utility function. Just to make it easy, it was not the most precise and mathematical definition of semi-strictly quasi-concavity, but I'm pretty sure that you know, all of you know this concept. And then agents are endowed with some guaranteed utility, a minimum guaranteed utility, util I. Okay. Now and then you will find some mentions to other assumptions, such as linear utility or expected utility, quite standard. The common favorite object. Okay, so basically common favorite object means that you are always willing to exchange one unit of this object F for or one piece, small piece of this object for an equivalent piece of some other object. Okay. The Inada property standard and Lipschitz continuity standard as well. If you need some further explanation, please interrupt me. We are going to assume that the allocation that we are studying is going to be feasible, of course. So the standard feasibility condition. So from now on, I will not mention feasibility, but it is, well, it is implicit, okay, that the allocation is going to be feasible. Individual rationality is a standard definition, as you see here. Okay, what you obtain has to be at least your minimum guaranteed utility. Pareto efficiency is the standard one. Also, weak Pareto efficiency is the standard one. We are going to use some intermediate concept as well of Pareto efficiency, which is called consistent weak Pareto efficiency. Consistent with respect to what? With respect to economy reduction. Okay, for a survey and a deep study on that, just follow Thompson. I mean, like, Thompson is the master of this kind of, you know, the insights on this kind of concept. He has a forthcoming book, indeed, on the concept of consistency. The idea is basically that weak Pareto efficiency is quite weak, to tell you the truth. Now it's really weak concept because since the satiation is perfectly possible here, because the consumption space is bounded, an allocation in which one individual is satiated and the rest of individuals receive very absurd allocation is weak Pareto efficient. Okay? By imposing consistency, what we're saying is that, okay, take any coalition, for instance, this satiated guy, and take this out of the allocation problem with his allocated quantities and analyze the remaining economy, it must be also weak Pareto efficient. Yeah. So imposing this consistency to economy reduction, we obtain an intermediate property. In the linear utility setup, indeed, in the random allocation I show in the 2017 paper that generically Pareto efficiency and consistent weak Pareto efficiency are equivalent, but there are exceptions. Okay, generically meaning, you know, the non-singularity of some matrix, but you know, I address you to that paper in order to that. But you can find exceptions in which Pareto optimality and consistent weak Pareto optimality are not the same. And bear in mind that we also do, throughout the paper, although I don't define them with precision here, we take epsilon approximations to both individual rationality and Pareto optimality, very standard. Formally, the idea of not justified envy, when I was talking about Anne and Ben, it's like that, okay? An assignment or allocation is not justified MB if you can find a couple of agents, I and j, so that I envies j, and at the same time, in j's view, i's allocation is acceptable. A stronger notion of, less demanding notion of no justified MB is the no strong justified MB notion, in which basically if I envies j, then the utility that j obtains from i's allocation is higher than the minimum guaranteed utility he has. Okay, so no justified MB and
Antonio,
no strong justified MB.
Sorry for interrupting. Probably, maybe it's common. It's evident in the previous papers, but can you maybe remind me where it makes sense to have this not justified envy, like in course allocation or any other problem? Can you motivate it a little bit?
A housing allocation with tenants, that would be one. You know, in our concept is an adaptation to a concept that is used in the ordinal setting by Yilmaz and Atanosoglu and Seturaman. And the idea is that, you know, you take, for instance, Yilmaz, and he says, okay, if I envies j, so it's a probabilistic allocation, but the endowment is deterministic. Okay, the j owns a house. Okay, and this sure allocation of j's house first order stochastic dominates what I is obtaining. Okay, so basically when I say here the utility is higher than, okay, so here you should obtain that the allocation that I in the ordinal setting, you obtain that the allocation that I has is not first order dominated by the house that J has. Okay. Right.
Okay.
So let's go to the main results. Okay. First of all, we obtain a general existence. It's not a constructive proof, so still pending to see a general mechanism that works. But at least we show that it is possible in the general environments. Okay. However, the price to pay is that Pareto optimality is just weak, and justified MB means no strong justified MB. Okay. In order to obtain better results and a procedure to obtain them, and here is where you know all the talk about pseudomarkets makes sense. Is when we start studying subsimplices. In that case, through competitive equilibrium analysis, we find a procedure to obtain an allocation that satisfies all the properties, individual rationality, Pareto optimality, and not justified MB without any sort of approximations or weak sense. But under the following, either one of the following conditions. Okay. Either there is a common favorite object and a strictly positive IR allocation, or a CI is large enough for each individual, meaning that, you know, virtually as a matter of fact, it is as if the consumption space were unbounded. So a third condition is that satiation implies strict positive bundle. You cannot be satiated consuming only one good. A fourth condition is the inada condition and minimum guaranteed utility higher than the utility obtained with 0. So either of these four conditions is sufficient. Okay, and we will see how we proceed, how the procedure works to obtain the allocation. Okay? And then moreover, what happens if none of these 4 conditions is met, we still have results. We can still obtain, with regarding subsimplices, good results. Assuming Lipschitz continuity, we can show the existence of a procedure to obtain that, an existence of individual rationality consistent with Pareto efficient and no strong justified envy allocation. Moreover, if the allocation is Pareto efficient, it is also no justified envy. Okay? And a generic property, if around the allocation, the utility functions are, so around meaning in a arbitrarily small neighborhood around this allocation, the utility functions are either linear or strictly quasi-concave. Okay, so basically, I am precluding king points or points in which we change from linear to strict quasi-concavity, so which we regard as generic, then we can guarantee that the allocation is individual rational, Pareto efficient, and no justified envy, which are the 3 properties without any sort of relaxations that we desired. And as a corollary, the random allocation problem, in the random allocation problem, or in general with linear utilities, we can always obtain an allocation that satisfies the 3 properties without any sort of relaxations or epsilon approximations. Okay, as for the general existence problem, it's not a pseudo-market approach. It's just an approach based on Nasker, Kuratowski, and Mastusiewicz. If you forgive me for my pronunciation, lemma. So basically, this I'm pretty sure that almost all of you know this lemma, or if not all of you. So basically, the idea is for a simplex triangle. So basically, there are 3 sets, and each set is closed and associated to a vertex. It's covering the vertex, and moreover, each union of 2 sets is covering the edge connecting the 2 associated vertices, and moreover, the union of the 3 sets is covering the whole triangle. Okay, this simple version of the KKM with a 2-dimensional simplex, the result is that there must be an intersection between the 3 sets simultaneously. Okay. So using the same idea, and Alavarian, in which he uses the approach of, okay, let's talk about the simplex, but the simplex regarding weights in the Pareto welfare, you know, the sum of weighted utilities, and using the same idea of the KKM lemma here, and we defined for each individual the set that is the set of weights guaranteeing epsilon Pareto efficiency, epsilon individual rationality, and no epsilon justified envy from I, and then we define it for each individual. There must be an intersection between all of them, and in this intersection you find an allocation that satisfies the desired properties. And the idea is then to take the limit as epsilon goes to 0.
Antonio, you have 4 minutes.
4 minutes. Then I focus on this idea. The pseudo-market idea is to make incomes price dependent. And we take as a reference the minimum cessation expenditure and the minimum IR expenditure. And your income is going to be the median between 3 values. Okay, the minimum cessation expenditure, the minimum IR expenditure, and some common average income. Okay, And the nice thing is that we can show competitive quasi-equilibrium, and either one of the 4 properties make the quasi-equilibrium to be automatically an equilibrium. And for that, individual rationality and Pareto optimality is immediate. And in order to see no justified envy, imagine that I envy J. Okay, of course, I must have less money than J. And we show in lemma 4 that it must be the case in such a case that J just has enough money to obtain IR, to obtain individual rationality. Therefore, the allocation that I obtains must be unacceptable for J. Okay? So it's quite, if you think about that, at the end of the day, it's not a difficult mechanism to understand. It's the median between three values. And it's smart, fine-tuned such that envy implies that the envied guy cannot accept the envying allocation in any sort. Theorem 3 is just the result of creating an artificial economy in which we introduce a common favorite good, and we make the supply of this common favorite good go to 0. Then just to say that we can extend the results to general linear constraints, and that also we can extend the results to general notions of not justified envy, such as cycles of exchanges, like individual 1 envies individual 2, who envies individual 3, and so on, who envies individual J, who has individual 1's allocation as acceptable. Okay, these kind of cycles cannot exist in the so our results extend to this property as well.
Antonio, can you please wrap up in 1 minute?
Yeah, just say that the allocation is so this procedure is manipulable, and this is not a surprise. If you have seen Gilmat and Antonosoglu and Seturaman, they also acknowledge that. One could argue that in large markets, this is not a problem, but it's not true. Okay, we show that even when prices cannot be manipulated by individual preference manipulation or are insensitive to them, there are still issues with manipulability, and we characterize in propositions 1 and 2 scenarios in which non-manipulability arises. Okay, so basically this is the idea. Okay, and for the policymakers, that could be an interesting alternative tool to utilize. Okay, instead of ceiling constraints, floor constraints, priorities, this is another idea. Okay, to justify some minimum satisfaction, if satisfaction can be standardized or normalized, satisfy some minimum percentage of satisfaction to some minorities or individuals that you want to protect. There is an idea. And that's another use of pseudomarkets. And as uses, school choice, time banks, allocation with unbounded consumption spaces, and so on. Okay, there are references, but I leave them there because there is no time. But you know, we also comment on the related literature as well. So for that, I'm done.
Thank you, Antonio.